Chucky boy? Spring is here.
Oh, don't bug me, Tech Man. I got me a bad case of spring fever.
I can't blame you, Chuck. It's a downright balmy day. Maybe we can snap out of it by talking about some new features on the 1959 air conditioning system.
Air conditioning? Gosh, Dave, aren't you kind of rushing the season?
I think Dave is right, Chuck. Unless we get cracking on it today, how are we going to be ready for air conditioning when hot weather really hits?
And besides that good point, I've got another reason. This car's been checked and made ready for delivery, except for the air conditioning system. Now, why don't we do the job together and get you acquainted with the new unit at the same time?
Well, looks like you got me coming and going. I gotta know the new changes, and here's my chance to find out. What can I say but okay?
I'm glad you see it our way. Now, there are three types of installations available. One consists of just the front unit, another is a combination of the front and rear units, and then there's a front and roof unit combination. Well, we'll just cover the front unit because it's the basic factory-installed setup. Operation of all units is very simple because of the new system of push-button controlled vacuum actuator units. These actuators operate doors and a damper to direct airflow to suit any owner's personal taste.
I know how those vacuum actuators work from our meeting on the heating system. The push button causes a sliding valve to vent one chamber to atmosphere and open the other chamber to vacuum. That in turn opens or closes a door or damper.
Yeah, that's right. And the push buttons also control electric circuits to the magnetic clutch and to the blower switch. In the end of the temperature control lever, there's a switch for the electric blower motor control. For low blower speed, push the knob in. For high speed, pull the knob out.
Yeah, and just to refresh your memory, Chuck, you push the button marked MC for maximum cooling. FC is for fresh air cooling. DEF is for defroster operation. H for heating. And off, well, that explains itself.
That's clear enough, but how does the air flow through the unit when the buttons are pushed?
Well, when you want maximum cooling, first move the temperature control lever to off. Next, push the MC button. Third, pull the blower knob out for high speed. With this maximum cooling setting, the fresh air door is closed, the recirculating door is open. Air inside the car will be conditioned, but no fresh air will be drawn in from outside. If the distribution duct damper is set for normal distribution, about 90% of the air will come through the instrument panel outlets. 10% comes from the floor outlets.
I see. Now, what happens when the FC button is pushed?
The FC button pushed in opens the fresh air door and closes the recirculating door. That pulls in fresh air, conditions it, and discharges it from the outlets in the same amounts as for maximum cooling. Moving the control lever regulates temperature by controlling water circulation through the heater core. About 75% of the air drawn in bypasses the heater core. The 25%, which passes through the core, is heated and mixes with the bypassed air in the distribution duct. That regulates temperature of the discharged air. Now, when you want defrosting operation, airflow is different. Slide the control lever toward the warmer end of the slot and push the defrost button in. This closes the bypass door. As a result, all outside air entering the opened fresh air door is directed through the heater core. Most of it also is discharged through the panel outlets.
You can ventilate the car when you want to without heating or cooling it. Just push either the defrost or heat buttons and move the temperature control lever to off.
Yeah, Tech's right. With either of those buttons in, all air is directed through the heater core. But with no hot water in the heater core, unheated, fresh air enters the car.
Okay, Dave, that's fairly clear.
Well, good. Now, we're going to give this system an overall operation and performance test. Such a test brings into play all mechanical, electrical, and chemical conditions involved. When a unit passes the performance test, we know it'll be satisfactory to the owner.
Yeah, but be sure to make that test only when room temperature is at least 75 degrees. You'll just kid yourself if you try the test when the room's colder than that.
Yeah, Tech's right again, Chuck. Here, suppose you hook up the test gauge set.
Okay, I'll have it done in a few seconds.
Now, with the gauge set connected, open the discharge and suction service valve stem 2 turns clockwise from their back-seated positions. Momentarily, open and close the gauge valves alternately. That will purge air from the hoses between compressor and manifold. Next, read the pressures and see if they're normal for the temperature according to the table in the reference book.
Well, supposing the pressures aren't okay.
Well, no pressure at all means the system's empty due to a leak. Now, in a case like this, you'd have to evacuate the system, put in a sweep test charge, find the leak, and correct it. And after that, you'd purge the test charge and replace the dryer. Then evacuate and charge the system with the proper amount of refrigerant 12. For the right charge, look at the specification chart.
Dave can tell you why he keeps a pressure-type can of refrigerant oil handy, Chuck.
Oh, yeah. You'll need it if you have to replace a piece of tubing or hose. You have to lubricate the threads of both connections and especially the turning surface of the female nut.
And here's another tip. Always use new copper gaskets when you reconnect brass to steel or steel to steel connections.
All right, Tech, I'll keep that in mind.
Good. And when you replace the receiver dryer, be sure to use the new gasket that comes with the dryer. 10 to 12 foot-pounds torque is what you need on the new dryer to dry eye connection.
10 to 12. Okay, got it.
Fine. Now, since our pressures were okay, check operation of the temperature control lever. Move it to extreme warm and back to off positions so you can check control cable action at the hot water valve. The control lever must travel the full length of its slot. The valve lever must be moved its full travel by the cable or the valve won't close or open fully. You can watch valve action as you move the control lever.
Boy, it took some doing, but our valve seems to be working all right.
Yeah, good. Now, remove the radiator cap, open the car windows, and move the temperature control lever to off position. Start the engine and run it at 1250 RPM.
1250, okay.
Push in the FC button and pull the blower knob to get high speed.
Hey, she's blowing up a storm. Guess the blower's wired up all right.
That's a good sign, Chuck. If the blower didn't work or didn't go at high speed, I suppose you know how to check out the wiring circuit and make it right, eh?
Yeah, Tech, that I can handle. What's next?
Well, the compressor clutch should be engaged and the system should be working. If the compressor clutch didn't engage, you'd have to check that circuit to find the trouble. Now, as an example, use the test light to check clutch wiring circuit and check contact of the brushes at the clutch.
I understand. Our clutch, though, is engaged and running all right.
Fine. Now, let's momentarily disconnect the heater outlet hose at the top of the heater housing to see if the water valve is closed.
Just a small amount of water, but there's no continuous flow. The water valve must be closing properly.
Right. Now, if it weren't closed, you'd have to recheck control cable adjustment. If that didn't work, you'd replace the valve and recheck it. You got that?
Still with you. What now?
Well, put the radiator cap back on, then we'll run the system for about 15 minutes. If the dry eye is blue, that's another check out of the way.
If that dry eye were pink or an orchid color, it means moisture is in the system. Know what that would call for?
It would mean purging the refrigerant, replacing the receiver dryer, and recharging, wouldn't it?
Right you are, Chuck. Now let's block the airflow across the condenser so we can boost discharge pressure up around 225 to 250 pounds.
Good point, Tech. Then we can check the sight glass for foam.
No foam in sight, fellas. Guess we can unblock the condenser and let discharge pressure fall.
Yeah, Chuck, and while you're doing that, let's ask somebody to lift the needle and gently try it on the other side of this hi-fi record.
If we had seen foam, we'd have to add refrigerant to clear up the sight glass, right?
Yeah, that would do it. You'd maintain discharge pressure at 225 to 250 pounds. At the same time, you'd add refrigerant gas through the suction side until the foam clears. Then you'd add exactly 1/2 pound more. If this were a dual unit, both blowers would have to be on high speed. Finally, unblock the condenser and let discharge pressure return to normal.
Simple enough. What's the next step?
Next, we'll test vacuum actuator operation. So cut engine speed down to idle, and that'll give us high vacuum and a quicker actuator response. push each button alternately and check for slow or improper door, damper, or deflector operation. Now, as an example, when you press the defrost or heat button, the bypass door should be closed, and the over-center lever and linkage will be in a straight line. If the bypass door doesn't close completely, the linkage may need adjustment, or the hose connections may be reversed. To adjust the linkage, loosen the lever pivot screw, slide the pivot and screw in its slot as you push the actuator rod rearward to close the door completely. Then, retighten the pivot screw.
I see, Dave. And I think I can handle linkage adjustment okay. But what about the hose connections being reversed?
That's a good question. Here's what you want to remember. Each hose to an actuator has either a gray or a red stripe. Hoses with the red stripe connect to the rod side of the actuator in all cases except on the bypass door actuator. On that one, it connects to the side opposite the rod.
I get it, Dave. Now, one more question. How do you test the actuators for vacuum leaks?
Well, you stop the engine and check the fit of the black vacuum hose connection at the intake manifold. It should be tight, of course. In addition, use this vacuum pump connected to the vacuum test set to make a leak test of the control system. Adjust the bleed valve to get a reading of 8 inches of vacuum while your finger blocks the prod on the end of the test hose.
Release your finger on the hose prod a few times and re-block it. The bleed valve must be adjusted so the gauge needle returns to exactly 8 inches when your finger covers the prod.
Okay, Tech, will do.
Disconnect the engine vacuum source hose at the plastic connection under the instrument panel. Insert the tester prod into the source hose that leads to the control switch. Then you can start the test. First, push the heat button. The vacuum gauge will read lower until the actuator works, and it will then build up. Try all the buttons and allow time for vacuum drop and build-up.
You shouldn't get a vacuum drop of more than 3/4 of an inch below the 8 inches of vacuum.
Looks like we've got an airtight vacuum control system.
Yeah, that's good news. If you did get a vacuum drop of more than 3/4 of an inch, recheck the tester to be sure it is adjusted to read 8 inches. If that's okay, then start checking with the 7-hole hose connector plug attached to the control switch. This plug must be positioned all the way on the 7 prods of the control switch. Don't lubricate the prods or holes, as that can ruin the vacuum valve in the switch. Now, if you can't position the connector plug all the way on any of the switch prods, use a drop or two of clean water in the holes. That'll help the plug slide completely on the prods.
Since this vacuum system checks out, Chuck, we can go on with our performance test. But you'll be glad to know there's more vacuum test information in this reference book.
Swell, Tech. I'll be sure to look it over.
Attaboy, Chuck. Now, check the condenser and subcooler fins for any foreign matter. If necessary, brush the fins clean.
Bent fins cut down the condenser area, too. You can use this condenser comb to straighten fins out to their original shape and efficiency.
All right. Now, what's the next operation?
Well, with the car window still open, move the temperature control lever to off. Adjust the distribution duct damper control stop, or the cable, to direct 50% of the air through the panel outlets and the other half through the floor outlets. Fully extend the outlet grills to direct airflow toward the rear of the car. Put the thermometer in the right outlet grill, start the engine, and adjust speed to 1250 RPM. Push in the fresh air button and pull the blower knob out for high-speed operation. Recheck to be sure you're getting 50-50 airflow up and down. If you ever make this test on a dual system, by the way, you'd leave the rear or roof unit blower turned off while you test the front end unit.
Okay, I'll remember that.
Here's something else. If the needle on the discharge gauge dances around too much, backseat the discharge service valve stem enough to reduce the jiggle, but don't close it off.
All right, I understand. Now, do you want me to close the hood?
Yeah, Chuck. Fix those hoses and tachometer leads so you can latch her up. In the meantime, I'll put this motorized psychrometer near the air inlet grill so we can get our wet bulb, dry bulb readings. In about 15 minutes, we'll have the car up to operating temperatures. How's the discharge pressure?
It's holding steady at 200 pounds, Dave. That's within the 190 to 210 range, so it's okay.
Fine. What's our dry and wet bulb temperatures?
80 degrees dry and 59 degrees wet. 80 and 59. What's the temperature of the delivered air inside?
It's about 47 degrees, Tech. Is that good?
Well, we'll know in a minute, Chuck. I've got the performance chart right here. Chart calls for 50, and we get 47 degrees. That's 3 degrees better.
What more do you want, Dave? Blood? I say that's as close as you'd want to get.
Yeah, that's pretty good, all right. But we still should make sure this unit keeps on delivering as well as it is. So let's check the thermal switch.
Where do you start that, Dave?
Well, you push in the MC button and push the blower knob in for a low-speed operation, Chuck. Now, see if you can feel the difference in speed at the outlet.
It feels a lot slower, Dave. Now what?
Now, close up the windows and doors, and let's watch pressure on the suction gauge. As the evaporator cools down, suction pressure should gradually lower. Now, what's more, when suction pressure is between 18 and 24 pounds, the thermal switch contact should open and de-energize the clutch.
Well, we'll know in a minute. Suction pressure is getting near 25. Oh, there she goes. Those contacts opened when suction was down to 22.
Hey, that's good. Now let's see if suction pressure starts a rapid rise.
Yeah, Chuck. When suction goes above 24 to 30 pounds, that clutch should be energized again.
Yeah, that's right. We've got to be sure this unit cycles properly. Now stand by a minute. Well, that clutch is back at work, and it happened at about 29 pounds. Let's run it a few more times to be sure those pressure changes and clutch engagements take place continuously.
Okay, Dave. And I guess this unit's going to keep the owner cool enough. But supposing the thermal switch had failed the test?
Well, if suction pressure didn't pull down enough to cycle the clutch, we'd disconnect the blower connection at the distribution duct. If suction pressure without blower operation got down below 15 pounds before the clutch de-energized, it would point to one thing: bad contact between the thermal switch sensing tube and the evaporator fins and tubes. If the suction pressure got below 10 pounds and still didn't de-energize the clutch, we'd know the thermal switch wires were shorted or the thermal switch was faulty.
I get it. And I'm glad our thermal switch proved out okay.
That goes for all of us, Chuck. And it's our job to make sure these units work the way they're designed to work. Besides the things we've talked about, there's a more complete service story in the reference book. Study it so you know how to make the tests and how to diagnose the non-standard performance causes. Then we'll all do right by our customers.